chemistry classes. In this video, we have to discuss here sulfur and its compound. Sulfur and its compound. Okay, first we have to discuss here allotropes of sulfur. Sulfur shows different type of allotropes. Rhombic sulfur and monoclinic sulfur. These are the allotropes of sulfur. Rhombic sulfur and monoclinic sulfur. Rhombic sulfur also called alpha sulfur. Alpha sulfur. It is yellow in color and it is stable at room temperature. Stable at room temperature. Next one, beta sulfur. Okay. So here, look here. These are the allotropes of sulfur. Okay. Rhombic sulfur and monoclinic sulfur. These are the allotropes of sulfur. Rhombic sulfur and monoclinic sulfur. Rhombic sulfur also called alpha sulfur. Rhombic sulfur also called alpha sulfur. It is stable at room temperature. Also it is yellow in color. Yellow in color. Okay. Next allotrope, monoclinic sulfur. Monoclinic sulfur also called beta sulfur. Monoclinic sulfur also called beta sulfur. Okay. Here, next point we have to understand here, alpha sulfur or rhombic sulfur can be converted into monoclinic sulfur at 369 Kelvin. When you heat rhombic sulfur at 369 Kelvin, it will change to monoclinic sulfur. Okay, so here allotropes of sulfur, rhombic sulfur and monoclinic sulfur. Rhombic sulfur also called alpha sulfur, monoclinic sulfur also called beta sulfur. Okay. Okay, next one we have to understand here more details about rhombic sulfur. Rhombic sulfur or alpha sulfur. Rhombic sulfur, melting point of rhombic sulfur 385.5 Kelvin. 385.5 Kelvin, its melting point. Specific gravity. Specific gravity of rhombic sulfur 2.06. 2.06. Okay. Rhombic sulfur formed by evaporation of sulfur solution in carbon disulfide. Sulfur solution in carbon disulfide. After evaporation, it formed rhombic sulfur. Rhombic sulfur insoluble in water, but it's soluble in organic solvents such as benzene and carbon disulfide. Okay. So here we discuss rhombic sulfur, melting point of rhombic sulfur 385.5, specific gravity 2.06. Specific gravity 2.06. Rhombic sulfur formed by rhombic sulfur crystals are formed by evaporation of sulfur solution in carbon disulfide. Rhombic sulfur insoluble in water, but it's soluble in benzene and carbon disulfide. Okay. Okay, next one we have to understand here beta sulfur, monoclinic sulfur. Monoclinic sulfur its boiling point 393 Kelvin. Its boiling point 393 Kelvin and specific gravity 1.98. 1.98 specific gravity. Okay. And here here monoclinic sulfur prepared by heating alpha sulfur in a dish. Heat alpha sulfur in a china dish, then cool it. Then we will obtain monoclinic sulfur. Okay, and we discuss it is soluble in carbon disulfide. Beta sulfur dissolved in carbon disulfide. Look here. Beta sulfur. Beta sulfur, we discuss about beta sulfur. Now we have to understand one more point. Alpha sulfur stable at 369 Kelvin. Okay, see here, alpha sulfur stable at 369 Kelvin. Alpha sulfur stable at 369 Kelvin. Above this temperature, alpha sulfur will transfer to beta sulfur. Alpha sulfur or rhombic sulfur stable at 369 Kelvin. 369 Kelvin it is stable, or below 369 Kelvin it is stable. Above 369 Kelvin, alpha sulfur will change to beta sulfur. Okay, at 369 Kelvin, both alpha sulfur and beta sulfur stable. So here we discuss at 369 Kelvin, alpha sulfur stable. Above 369 Kelvin, alpha sulfur will transfer to beta sulfur. Also you understand at 369 Kelvin, both alpha and beta sulfur stable. But when you increase temperature above 369 Kelvin, alpha sulfur will change to beta sulfur. Clear? Also we have to understand here, sulfur, both alpha sulfur and beta sulfur exist in the form of S8. Polyatomic molecule. Sulfur, it is polyatomic molecule. Polyatomic molecule means one molecule of sulfur which contains 8 sulfur atoms. Both alpha and beta sulfur, both rhombic and monoclinic sulfur which exist in the form of S8. Okay, S8 means they have puckered ring structure. They have puckered ring structure. Okay, so they are polyatomic in nature. Also you understand sometimes sulfur exists in the form of S6 also. So sulfur exists S8 and S6. 6 sulfur atom and 8 sulfur atom. If there is 8 sulfur atom, it will be in board form. You can see here figure. Here sulfur exists in S8. It will be board form. Sulfur exists in S6, then it will be chair form. Okay, sulfur exists in the form of S8, it will be board form. Sulfur exists in the form of S6, then it will be chair form. You can see here chair form and board form of sulfur. Okay, next one we have to understand here compounds of sulfur. Compounds of sulfur, first one, sulfur dioxide, SO2, sulfur dioxide. Sulfur dioxide formed by burning of sulfur. Sulfur containing fuels or sulfur after burns, it forms sulfur dioxide. Okay, laboratory method of preparation of sulfur. Laboratory method of sulfur. Sulfide compounds after reacting with acid, it forms sulfur dioxide. Sulfite reacted with dilute acid, it forms sulfur dioxide and water. Industrial method of preparation. In industry, sulfur dioxide formed as byproduct. Sulfide ore, for example, zinc sulfide. During extraction of zinc, sulfur dioxide formed as a byproduct. It formed as a side product. Okay, so here we have to understand about sulfur dioxide. Here sulfur after burn, it forms sulfur dioxide. Laboratory method of preparation of sulfur dioxide. Sulfite compound, after reaction with dilute acid, it produces sulfur dioxide and water. Sulfite means SO3 2-, it reacted with the dilute acid, it forms sulfur dioxide and water. Industrial method. In industry, sulfur dioxide it formed as a side product. For example, FeS2. Okay, iron ore which contains sulfur after oxidation, after reacting with oxygen, it forms iron oxide and sulfur dioxide. So here sulfur dioxide it is side product. Another example, zinc blend. Zinc sulfide after oxidation it forms zinc oxide and sulfur dioxide. So in industrial method of preparation of sulfur dioxide formed as a side product in industry during extraction of metals. Okay, next one we have to understand here properties of sulfur dioxide. Properties of sulfur dioxide. Sulfur dioxide, it is colorless gas with pungent smell. Sulfur dioxide, it is colorless gas with pungent smell. Sulfur dioxide, it liquefy at room temperature and pressure. It liquefy at room temperature and pressure. Sulfur dioxide, it boil at 263 Kelvin. It will boil at 263 Kelvin. Sulfur dioxide, it dissolve in the water and it form sulfurous acid. Sulfur dioxide, it dissolve in the water and form H2SO3. H2SO3 means sulfurous acid. H2SO4 sulfuric acid, H2SO3 sulfurous acid. Okay, and this chemical reaction is exothermic reaction. Sulfur dioxide dissolve in the water and form sulfurous acid. This chemical reaction produce heat energy and it is exothermic reaction. Okay, sulfur dioxide react with sodium hydroxide and form sodium sulfite. Sulfur dioxide reacted with NaOH, it form sodium sulfite, Na2SO3, sodium sulfite. Sodium sulfite again reacting with the sulfur dioxide in presence of water, it form NaHSO3, sodium hydrogen sulfite. Sodium hydroxide, here we discuss sodium hydroxide reacted with the sulfur dioxide, it formed sodium sulfite. Again sodium sulfite reacted with sulfur dioxide in presence of water, it will change to sodium hydrogen sulfite. Okay, and here another chemical reaction, sulfur dioxide reacted with the chlorine, it formed sulfuryl chloride. Sulfur dioxide reacted with the chlorine, it forms SO2Cl2, sulfuryl chloride. Sulfuryl chloride. Okay, SO2Cl2, this compound is called sulfuryl chloride, and this chemical reaction catalyzed by charcoal. This chemical reaction takes place in presence of charcoal. Here charcoal acts as a catalyst. Okay. Also here sulfur dioxide, it decolorizes potassium permanganate. We know potassium permanganate, it is purple color. When we pass sulfur dioxide through potassium permanganate solution, it will decolorize potassium permanganate solution. So here we discuss properties of sulfur dioxide. Sulfur dioxide, it is colorless gas with pungent smell. Sulfur dioxide, it liquefy, it will change the liquid state at room temperature and pressure. Sulfur dioxide, liquid sulfur dioxide, it will boil at 263 Kelvin. Sulfur dioxide dissolve in the water and form sulfurous acid, it is exothermic reaction. Sulfur dioxide reacted with the sodium hydroxide, it formed sodium sulfate. Sodium sulfite. Okay, here sulfur dioxide reacted with sodium hydroxide, it formed sodium sulfite. Sulfite means SO3 2 minus. Sulfate means SO4 2 minus. Here sulfite SO3. Sulfate SO4. Okay, so here sodium hydroxide reacted with the sulfur dioxide, it forms sodium sulfite. Sodium sulfite again reacted with sulfur dioxide in presence of water, it will change to sodium hydrogen sulfite. This compound is sodium hydrogen sulfite, NaHSO3, sodium hydrogen sulfite. Okay. Then we discuss sulfur dioxide reacted with chlorine, it formed SO2Cl2, sulfuryl chloride, SO2Cl2. This chemical reaction catalyzed by charcoal. Sulfur dioxide, it decolorizes potassium permanganate. When you pass sulfur dioxide through aqueous potassium permanganate, here oxidation takes place and potassium permanganate, it will change to its purple color will be colorless, decolorized potassium permanganate solution. Okay. Okay, next one we have to understand here sulfur dioxide. Sulfur dioxide, it is angular shape. Sulfur dioxide, it is angular in shape. Also it shows resonance structure. These are the resonance structure of sulfur dioxide. Resonance structure of sulfur dioxide. Okay, next one we have to understand here different uses of sulfur dioxide. Different uses of sulfur dioxide. Sulfur dioxide used in refining of petroleum and sugar. To refine petroleum and sugar, we will use sulfur dioxide. Sulfur dioxide used as a preservative, food preservative. Okay. Also sulfur dioxide, it used as a bleaching agent in paper industry. Sulfur dioxide used as a bleaching agent in paper industry. Okay. Also here some other sulfur dioxide also used for bleaching wool and silk. Sulfur dioxide used as a bleaching agent in paper industry. Also it used in bleaching wool and silk. Okay. Also sulfur dioxide used as disinfectant. It used as a disinfectant and food preservative. Also it used as anti-clor. Okay. Also liquid sulfur dioxide used as a solvent to dissolve many organic and inorganic substance. Many organic and inorganic substance. So these are the different uses of sulfur dioxide. Sulfur dioxide used in refining of petroleum and sugar. Sulfur dioxide used as a bleaching agent in paper industry. Also it used in bleaching. It used for bleaching of wool and silk. Okay. Also it used as disinfectant, food preservative and anti-clor. Okay. Sulfur dioxide used for the manufacturing of sulfuric acid. This is very important use. Sulfur dioxide used for the manufacturing of sulfuric acid. This process is called contact process. Contact process. Okay. And here sulfur dioxide also used to make sodium hydrogen sulfide. Sodium hydrogen sulfide, calcium hydrogen sulfide. Okay, look here, sodium hydrogen sulfide and calcium hydrogen sulfide, sulfuric acid. Okay, so sulfur dioxide used in the production of sulfuric acid, calcium hydrogen sulfide and sodium hydrogen sulfide. Liquid sulfur dioxide used as a solvent to dissolve many organic and inorganic substance. So these are the different uses of sulfur dioxide. Also we discussed sulfur dioxide, it is angular in shape. Also it shows different resonance structure. Okay. Okay, next one we have to discuss here oxo acids of sulfur. Oxo acids of sulfur. Okay, look here some important oxo acids of sulfur. H2SO3. H2SO3 means sulfurous acid. H2SO3 means sulfurous acid. H2SO4. H2SO4 means we know sulfuric acid. H2SO4 sulfuric acid. H2S2O8 peroxo disulfuric acid. H2S2O8 means peroxo disulfuric acid. Peroxo disulfuric acid. H2S2O7. H2S2O7 means pyrosulfuric acid. Pyrosulfuric acid, that is H2S2O7. Pyrosulfuric acid also called oleum. Okay, so here you have different oxo acids and their structure is given. Okay, H2S2O3, H2SO3. H2SO3 means sulfurous acid. H2SO4 means sulfuric acid. H2S2O8 means peroxo disulfuric acid. Peroxo disulfuric acid. H2S2O7 pyrosulfuric acid or oleum. So these are the things we have to discuss here. Okay, sulfuric acid, production of sulfuric acid, contact process, we will make another video. Okay, so thank you for watching this channel.